What's up, 7th graders? Today we are starting our new module on probability and likelihood. Today is just an introduction to some of the vocabulary that we're going to be using throughout the unit. This is module 12-13, so we're covering two 7th grade modules. I hope your test went okay yesterday. Let's go ahead and jump into the content. For likelihood, when you hear this word likelihood, you think how likely or how much in favor am I of winning something, of rolling a certain number, of spinning a spinner and landing on a certain amount. And likelihoods can be put onto a number line. They range from a 0% chance to a 100% chance of something occurring. When it comes to probability, we think in terms of percents, fractions, whole numbers, decimals, and the words impossible, unlikely, as likely as not, likely, and certain. So if I break up this number line and try to make sense of an impossible probability, that would be like spinning a color on this spinner that has no color. There's no color on here, so my probability of spinning a color is 0%. On this next one, because there's half one color and half no color at all, that's as equally as likely as it is not, so like a 50% chance. And as you can tell, 50% of the spinner is filled in. In between those two, we have this word unlikely. That's any percent between 0 and 50%. And then in between 50% and 100% certain would be from 51% to 99%, or from 50 to 100, in that range. And if you're curious about what a 100% chance of spinning the color green would be, that would be this one right here. You have 100% certainty that you will spin a green because the entire darn thing is green. Space. Sample space is kind of like the population you were sampling when you were doing surveys. It's the total possible outcomes of an experiment. When we use the word experiment, we are referring to an event that happens. For example, spinning this spinner. That's an experiment. Every time I spin it is a trial or an experiment. Now the sample space is all possible outcomes for this spinner. I see that there are 5 outcomes, but the sample space is the list. My sample space isn't 5. 5 is one of the possible outcomes. Take a look at this number cube. I see 4, I see 3, I see 2, but what I don't see in the back here is the other numbers. A number cube has a list of 6 numbers. So although there are 6 possible outcomes, 6 is one of those possible outcomes. How about in a rainbow? So each one of those is a possible outcome. And finally, for another example, flipping a coin. 2 outcomes, but the list is what we need, the list of both. A little more complicated and further down is the possible outcomes for a deck of cards. So decks of cards come in 52. So there's a pack of 52 in a deck, and there's multiple different ways to label your deck of cards. In a deck of cards, you have 4 suits. Inside each one of those suits are 13 numbers. Inside each one of those, you have 4 aces, 4 twos, all the way over. Face cards versus non-face cards. You could also label them as black versus red. So you can split 52 up into a bunch of different samples from this sample space of 52 cards. Here's just a small list. Now that we know a little bit more about sample spaces, let's try to solve some problems and find some probabilities. Probabilities are likelihoods of an event occurring. how would you describe the given probabilities? Would it be impossible, unlikely, as likely as not, likely, or certain? Let's read. What is the likelihood of flipping a heads on a coin? To find probability, you may have seen this in the past, it is the number of favorable outcomes divided by the number of possible outcomes. So you're always going to set this up like a ratio of division. Flipping a heads is the favorable outcome, and we're going to divide it by the number of possible outcomes on a coin. We know that a coin has 2 possible outcomes, so our ratio is going to be 1/2. So 1/2 is 0.5 as a decimal, and that becomes 50% as a percent. So if we're looking at likelihood, the first problem is as likely as not, because it is exactly 50%, and that's what we're looking for. So this is C, as likely as not. Looking at the next one, what is the likelihood of rolling an 8 on a 6-sided number cube? Rolling an 8 would be favorable. Well, now I need to look at my sample space. A 6-sided number cube has 1, 2, 3, 4, 5, and 6 as possible outcomes. So if I look at 8, there are 0 possible outcomes out of 6. So in this case, 0 divided by 6 is 0% chance, which makes sense because there's no 8 on a 6-sided number cube, so that's going to give us A for the second one. Moving on to the next one, what is the likelihood that the sun will rise tomorrow? This is one of those tricky ones, but is most likely 100% certain that the sun will rise tomorrow. You could make the argument that it might not. There's always a chance, but to the best of our knowledge, this is E, the sun will rise tomorrow. What is the likelihood that we have school tomorrow? Well, today is Tuesday, tomorrow is Wednesday, and there's no day off, so there is a 100% chance of school tomorrow pending no snowstorm. So you could say 100%, or you could say likely, which would be between 100% and 50. So I would go with D or E. Most times there's a definite answer, but in these situations, D or E. What is the likelihood that it will be 60 degrees tomorrow? Checking the weather, it's still winter. It is very unlikely, so I would go with unlikely because of the season. All right, 7th graders, that about wraps up today's lesson on sample space and finding probability and likelihood on a number line. We're going to get more in depth tomorrow on finding actual probabilities. Thanks for sticking around. Ask your teachers if you have questions. Good luck.